Page 529. We've got a whole bunch of tools that we can use so that we can actually answer question 7. But here it is from the blank start to finish. If you notice that we want to divide or segment this partition, I keep saying segment, I mean partition the directed segment PQ into a 1-to-2 ratio, somewhere over here will be the first segment, and then over here will be the double, the 2 of the 1-to-2 ratio. What I'm going to recommend from the previous few videos, the previous few pages, is we draw point Q, we draw another point, maybe I'm going to call it point R, on the bottom, like on, oh, it's so leggy, sorry about that, on this edge of the screen, on the x-axis. So I'm going to count straight down. 1, 2, 3, 4, 5, 6, 7, 8, 11. This is at a height of 14. So that's 14 spaces down. A 1-to-2 ratio is cutting the segment, or partitioning the segment into thirds. That's a vocab word I need to highlight. Partition means to cut, but to cut it in such a way that there is definitely like a part over there that is not going to be a part over there. So it's separating the two sections of the line. If I'm going to cut it into thirds, and I'm going to draw a line straight down, I shouldn't draw the line straight down from P, because straight down from P is 14 spaces. Let's hope Q is a number that can be divided. Q to the x-axis is a number that can be divided by 3. So 1, 2, 3, 4, 5, 6, 7, 8. It is. There's point R. It is 9 spaces down. And oh my gosh, use a straight edge, not your like shaky drawing of the finger here. Okay, next I'm going to connect PR because we need a triangle. Again, this whole thing is based upon the triangle proportionality theorem. So because of the triangle proportionality theorem. Now we're going to divide QR into 3 sections because 1-to-2 ratio is a 1/3 partitioning. 1, 2, 3, 1, 2, 3, and just to check it out, 1, 2, 3. Okay. I have to use the slope of PR, which I'll use this notation. The slope of PR is a fraction. And that fraction is going to be the change in the y-axis, or the y height, divided by the change in the x location. So I counted this already to be 14. And I counted over, let's see, 7 up to 24. So 3, 8, 13, 14, 15, 16, 17. 7 to 24, 17, yep. And it's also heading from P to R in a downward fashion, so the slope has to be negative. Now I'm going to use that from this point, to go put a dot up here somewhere. Oh, here's the trick. I can go straight up from P 3 spaces. 1, 2, 3. And then because this gap right here is 3 spaces, I can just go up from P 3 spaces and then draw my line. Draw it longer, longer, longer. We'll call this line 2. And then I can do the same thing for this point. It's 3 more spaces up. So if I count up 1, 2, 3 more spaces, connect them with the straight edge by drawing a line. They happen to all of them be parallel. This is line 3. And these are the locations where the segment is cut into thirds. Neither of these numbers are nice. That's the thing that's going to make this so frustrating. If I count down this way, 1, 2, 3, 4, 5. Yuck. So this is only a change in that direction of 5 and 17. None of those numbers are nicely divided by 3. So that will be somewhat of a problem. And here's where I'm going to have to use the extra technique from the other page. But I've got all of page 7 to do this. Now, I need to first of all find the equation of line 2. And the equation of line 2 follows the point-slope formula. Point-slope formula, y minus y1 equals m times quantity x minus x1. I know what my slope is. This is always the same value. And then over here, I need a coordinate that lies on line 2. So this is the coordinate 24, 3. Line 2 has the coordinate 24, 3. Line 3 has the coordinate 24, 6. Now I'm going to take both of those pieces of information and put them together. The other thing, the final thing, is to find the slope of PQ. And because PQ is on a downward direction, it will be negative, but it's going to be change of y, 5, over change of x, 17. That 17 is actually, I think, what is saving this question so that the fractions will not be that bad. But they are going to be irritating fractions at first. I also have one more setup to do. Long video. I'm trying to stay in line in a linear path, but I do recognize sometimes along the way I got to grab that skill or that topic, and I got to grab another topic and put them together. So all of the funneling of what we have to do is finally getting ourselves ready. I'm going to add y1 to both sides and then rewrite the point slope formula as y equals m times x minus x1 plus y1. With this one, I'm now ready to go. The equation for line 2 is y equals m negative 14 over 17 times x. Now I got to use the x coordinate here. So line 2 has 24 as its x coordinate and 3 as its y coordinate. Line 3, same setup. Y equals slope times x minus the x coordinate plus the y coordinate. I also need to know the equation of the line for PQ, which has a slope of negative 5 over 17. And P is located at 7, 14. So 7 in the x direction and 14 in the y direction. So I'm going to take, I'll write it this way. I'll write it as PQ has the line value of y equals the slope times the x minus the x coordinate plus the y coordinate. And I'm writing big on this paper so that I can make it be visible for the video, which means I am going to need some extra paper to continue the math. If you are writing small, you may be able to fit all of this math on this page, but if you're not, bring in some more paper. Now, in order to find the x coordinate where the lines cross, so like line 2 crosses PQ right here, that's not on the grid. So it's not going to be a nice whole number, which means I have to do this step. I'm going to take PQ and that equation, and I'm going to compare it to line 1. They both have y equals. So really, their y coordinates are going to be the same right there. I don't know what that is yet, though. So I'm going to have to do this method of take the other side of the equation and, in fact, I'll title it this way, line 2 to PQ. I'm going to take the line 2 equation, x minus 24 plus 3, and I'm going to set it equal to the PQ equation. Negative 5 over 17 times x minus 7 plus 14. Now I'm going to go solely on my scrap or extra paper. My extra paper, it's not scratch paper. It is like continuing my notes. So my notes are now on this extra paper here. Now, when we have an equation where the left side of the equation and the right side of the equation have fractions in them, the best method moving forward is to get rid of the concept of fraction. And we can do that by multiplying everything by the denominator. Both sides are going to be multiplied by denominators of 17. Remember where that 17 came from? It's the x direction. So if I multiply everything by 17, I'm going to multiply the fraction that has 17 on the bottom. So that's gone. Gone is the wrong word. That 17 has reduced to 1. The 14 is not reduced, though, because it's not part of the number we're multiplying by. So I'm going to have the 17 times 14 seventeenths reduce this fraction so that it's now a whole value of negative 14 times quantity of x minus 24. You also have to distribute. So the 3 is also multiplied by 17. Hey Siri, what's 3 times 17?
3 times 17 is 51.
Okay, so this is what happens when we multiply the left side of the equation by 17. On the right side of the equation, we're multiplying by 17, so the 17 reduces, which means that this fraction no longer has a denominator other than 1, which we're not going to write. Keep writing the rest. But just like we did over there, we have to distribute the 17 times 14. Hey Siri, what's 17 times 14?
17 times 14 is 238.
Okay. So right now, my first step was to make sure we have no fractions. Now we do have something that's complicated. The numbers are large, but we can distribute, combine like terms, subtract, and divide. I'm going to do this distribution first. I'm going to do negative 14. This is one method. You could do a different method. I'm going to do this method. You could do negative 14 times x and negative 14 times negative 24. Negative 14 times x makes negative 14x. However, hey Siri, what's negative 14 times negative 24?
Negative 14 times negative 24 is 336.
So I did that math right there with the distribution. I did nothing with the 51 yet because it wasn't part of the distribution. It was outside and beyond the parentheses. Now I got to go to the other side of the equation and do the same thing. Negative 5 times x and negative 5 times negative 7. I know what negative 5 times negative 7 is. It's positive 35. So I'm not going to ask Siri for that one. But I am going to ask Siri, or do I need to? I'm going to try to mental math this just a little bit more. So I'm going to combine like terms because I have 336 plus 51. Just on that side of the equation, just add those numbers together. 336 plus 51 should be 387. Over here, 35 plus 238. I'm adding. They're like terms because they're just constants. So 35 plus 238. The 8 plus 5 makes 13. Carry the 1. 1 plus 3 makes 7. And then the 200 is the last number, the 273. Drop down the other numbers. We did not do anything with the negative 14x, so it still has to be there. We did nothing with the minus 5x, so it still has to be there. And now we have negative 14x plus 387 equals negative 5x plus 273. They're just big numbers. But there's nothing more complicated than this, than the simplified question that your 8th grade math teacher showed you, or that your Algebra 1 teacher will or has shown you, that these are only just big numbers. That's it. And these are negatives. That's it. Otherwise, the same thinking applies. Get the x's to the left, get the to one side. Left is the most common side. Get the variables to one side, get the constants to the other, and you've solved it. I'm going to do that, but I'm thinking intelligently about how I want to have a positive x, for my math. So I'm going to add I'm going to cancel the negative 14 by adding its inverse, plus 14x plus 14x. Now I'm doing this plus sign because I'm doing it on both sides of the equation. There is this equal sign in the middle, and I'm going to add 14x on the left, so that becomes 0. And over here on the right, I'm going to add 14x because I added 14x on the left, and this will keep the equation balanced. But now I can combine like terms. So minus 5x plus 14x is 9x. While I'm here, I might as well do one more step, and that is to subtract both sides by 273. Since my motion moved x's away from the left side of the equation over to the right side, I should also, in this moment, subtraction, property of equality, subtract the same thing from both sides so that on this side, I get my 0. You should be getting zeros on both sides, but different color. Now, subtraction, I have 387 minus 273. That is a 4. That is a 1. That is a 1. So 114 plus 0 equals 9x plus 0. So really, it's just 114 equals 9x. Do I have to tell you what the next step is? I think I've talked to you most enough that you know. Do it. Hey Siri, what's 114 divided by 9?
114 divided by 9 is approximately 12.6666.
That is the x coordinate on the grid where L2 crosses the line segment PQ. All of this work, good work, amazing work, algebraic work. We're not even done yet, okay? We're not even done. After you find the x coordinates, now you go back to either of those two equations, maybe the L2 equation or the PQ, but you replace x with this number and then solve for y. I'm going to pick PQ just for consistency's sake. So PQ has the equation y equals negative 5 over 17 times x minus 7 plus 14. That's what I have from earlier in the page. But because I found out that x equals 12 2/3, that's the location where PQ is segmented, I'm going to take the 12 2/3 into this problem and keep solving it. Let's see if I can talk Siri through it. Hey Siri, what's 12 2/3 minus 7?
12 plus 2 over 3 minus 7 is approximately 5.6666.
Hey Siri, multiply that answer by negative 5/17.
Okay, I found this on the web.
Doesn't want to
Multiply
do it.
that answer by-
So at this point, calculator work is going to say, I'm going to go 5.6 times negative 5 divided by 17. And I get negative 1 2/3. So this reduces to negative 1.6. We're going to add 14 still. So I'm going to write now plus 14. I get 12 1/3. Oh my gosh, it's right there in the middle. So 12 1/3 is the final answer. And I put this into a coordinate, then I'm going to go back to the graph just to check it. I'm saying that this needs to be like a point. What coordinate do I have this being called? I didn't put a coordinate here. I'm going to put A as my coordinate and B as my coordinate. A is at 12 1/3. No, 12 2/3. Sorry, that's the x. This is the y. 12 2/3, comma 12 1/3. And if I check, that's right. I could also further project it, although I'm not asking you to in this moment. You could go find B. Where is B located? You do it in the same fashion. Good for the practice, good for the exercise. Thank you for sticking around for all 3 pages of Activity 3. It's a doozy. And I promise you, I won't ask you something so stressful in a stressful setting, but I will ask you to be able to understand how to use the grid to find the location that partitions the segment into a ratio. And I know what that ratio is referring to. Thanks for watching this video. Talk to Talk is last. It's next, and I'll see you in the next episode. Have a good one.